Hey everybody, welcome back. So we're going to talk about the difference between molecular and full ionic equations here. So for instance, if we go back to one we wrote earlier, so if we take something like silver nitrate and we react it with, say, something like magnesium iodide, and they swap partners and we get silver iodide and we get magnesium nitrate. And we applied the solubility rules, and we saw that the magnesium nitrate was soluble, but the silver iodide was insoluble. Hence we wrote an S down there. And I don't think that's balanced, is it? So I think we need to put a 2 in front of the AgNO3 to balance it off. Okay, this is technically called the molecular equation. So this is the molecular equation. And the reason it's called molecular is because, as far as we can tell, right? I mean, we know it's ionic, but we've written it out as if they were all molecules. And the full ionic equation, actually what it does is emphasizes the fact that if it's ionic and it's soluble, it actually breaks down into ions. So in the full ionic equation, basically the rule is we break down all the soluble ionic compounds into ions. Okay, anything else we leave alone. Okay, so for instance, if we have a precipitate, we basically just leave it alone. If we make water, we basically leave it alone. If we make CO2, these are all molecules, by the way, they wouldn't break down anyway, we just leave them alone. So we only break down the soluble ionic compounds into ions. So a big mistake is to take the solid and to break it down, but of course it's not soluble, so it doesn't break down. All right, so this gets a little tricky, right? So the silver nitrate, if we write it, when it dissolves, it breaks down and it forms silver ions and it forms nitrate ions. And because they're dissolved in water, we write AQ next to each one. But we don't just have one of each. Remember that coefficient of 2 meant we've got 2 silver and we got 2 nitrates. And the same thing here with the magnesium iodide. The magnesium ion, okay, it's broken down in water. And the iodide ion is broken down as well. And remember, iodide, right, is just a monatomic ion, A minus, and the coefficient of 2, right, tells you got 2 of them here. Now, why do we write a subscript there? Well, in the formula, we needed 2 of these to stick to one of these. And in the formula, the rule of thumb is we write a subscript. Now, when they're broken apart and separated, the rule of thumb is we write a coefficient. So it's just a convention. It doesn't really mean anything terribly important, but it's just like driving on the left versus the right side of the road. You better pick to a convention and stick to it. Now, the silver iodide on the right-hand side, because it's not soluble, it is not breaking down. So we just go ahead and leave that as is. And then the magnesium nitrate, again, I ran out of room, so magnesium Mg2+. And then the nitrate, remember, nitrate's NO3 minus, it's soluble in water, AQ. And although we use a subscript 2 in the formula, when it breaks down, there's just 2 of them. They don't stick together because negatives repel. And so we put a coefficient in front. So it looks something like that. That is what we call the full ionic equation. All right, you ready to try another one? All right, let's go for it. Okay, so here's one to try. Maybe we've got sodium sulfate. And we have something like lead nitrate, maybe? Lead 2 nitrate? Why not? Lead, delicious but deadly. Can you go ahead and write the full ionic equation for this one out? And for this one here, right, you'll have to start with the molecular equation and move on. So the molecular equation, right, we know that we've got sodium ions, we got lead ions. We don't know the charge on lead, though, but we can figure it out by the counter ion. So the counter ion is NO3 minus. I guess we got 2 of them, so we could write it out. And that lets us know the lead must have a equal and opposite charge. And if we're going to keep things consistent, I suppose technically we got 2 sodiums on the left and the right. So double replacement means that they both switch. So the sulfate and the nitrates basically switch partners. So on the right-hand side, we've got the sodium and the lead and their original position, and they have now paired up with nitrate and sulfate. And we can actually see that they both come together 1 to 1. So they've got equal and opposite charges. So sodium and nitrate +1, -1, like so. Lead and sulfate, +2, -2. So we only need one of each. And remember, we don't write the charges for the formulas out, but we always do when we have naked ions. It's not a balanced equation. We got 2 sodiums on the left, so we need 2 on the right. That puts that coefficient there. 2 nitrates now equalizes 1 lead, 1 sulfate. So everything is hunky-dory. And if we apply our solubility rules, we find that all sodium salts and all nitrates are soluble. So we can write AQ there. And we see that sulfates are generally soluble, but in the case of being paired up with lead, it is insoluble. So that was the molecular equation. Okay, and now we want the full ionic. And so in the full ionic, we go ahead and we just break down everything that is soluble in ionic. So we've got sodium, and we got 2 of them, so we use a coefficient of 2. Looks like that, and we got our sulfate. Okay, so there we go. And then we got our lead, and we got 2 nitrates. So remember, we put a coefficient in front of them, right? They're no longer stuck together. So that is the left-hand side, right? So there's the 2 sodiums. They've broken down, so there's the 2 in front of them. There's the sulfate. Okay, remember, we write the charges on the naked ions. The lead, we discussed earlier, was 2 positive. There's 2 nitrates, and we put a coefficient because they're no longer stuck together. And on the right-hand side, the sodium nitrate. Let's see. So it's aqueous, so we break it down. So there's sodium AQ, and there is nitrate AQ, and the coefficient means that there's 2 of each. And then what about the lead sulfate? Well, the lead sulfate is not soluble, so those ions are not broken down. So we just write it like so. So that would be the full ionic equation. All right, you want to try another one? Okay. Okay, so here's one for you to try. Can you predict the products, balance the equation, and write out the molecular equation, and then underneath write the full ionic equation? And so go ahead and pause the video and try it and compare notes, and in a couple of seconds I'll start going through it. All right, so let's go through it. So barium is in group 2, so we know it's 2 positive. Lithium's in group 1, so it's 1 positive. We got 2 of them, so I guess we can keep track of that. Br2, well, bromine, the element by itself, is Br2, but this is actually Br minus, and the 2 is just telling us that we need 2 of them to cancel out the charge on the barium. And on the other side, we got sulfate. That's one of those polyatomic ions, so SO4 2 minus. And then in double replacement, right, essentially we're just playing the old switcheroo game, so we just switch them around. So now the barium and the lithium, right, are paired up. Each one of them gets something new, so the barium gets paired up with sulfate, and the lithium gets paired up with bromide. And we can go ahead and we can do the crisscross, right? We can do 2 to 2, and actually 2 to 2, remember, simplifies the 1 to 1. And there, of course, we've got 1 of each, and we never write the 1s in, do we? So we can write on the line above BaSO4, and next to that we can write LiBr. And I'm going to try not to forget now, because last time I didn't balance the equation, and I should balance that. I can notice there's 2 lithiums on the left, and I've only got 1 on the right, so if I put a coefficient there, that works. I got 2 bromides on the left and the right, that's cool. I got 1 barium and 1 sulfate on the left and the right, so everything is hunky-dory. And if I pull out the solubility rules, I see that lithium compounds are soluble, so I write an AQ, and I also see that sulfate compounds are soluble unless there's barium involved. And so because you've got barium involved, oh, I almost wrote the wrong thing, right? So it is not AQ. What do we write if it's insoluble? Yeah, we write an S, and we can write a down arrow if we want to. So that is the molecular equation. So the next thing we want is the full ionic, and in the full ionic, basically we just take everything that's soluble and ionic and we break it down. So the barium bromide, that's barium and bromide. So the naked ions, right, we write the charges out and we break them apart. We got 2 lithiums and we got 1 sulfate, so that is everything on the left, and I don't think I gave myself enough room, and so I'm going to go to the new line, and then we got barium sulfate. Remember, we don't break it down, so the insoluble compounds and things like water and CO2 we don't break down, but the lithium bromide surely breaks down. So you got lithium, and I didn't win any handwriting awards, sorry, and bromide. And remember, the coefficients right now apply to everything here. There's 2 lithiums and there's 2 bromides. So that is the full ionic equation.